This is the first of two videos in which we learn how to determine the formula of a compound. Now in this first video we're going to discuss the strategy for solving this problem, and in the second video we're actually going to run the numbers to see how all the steps fall into place. Now this is a very interesting problem because it brings to the table a lot of the things that we have learned until now. For example, molar mass, number of moles, and percent composition of elements in a compound. Okay, so this is the problem at hand. Suppose that you have a compound and you don't know what the formula is, but you know what the elements in the compound are. So for example, suppose that you have a compound formed by carbon, hydrogen, nitrogen, but you don't have the formula. You don't know these coefficients x, y, and z. Okay, so the question is, what type of experiments can you do in order to be able to determine those x, y, z coefficients and then the formula of the compound? Okay, the idea is as follows. Notice that, let's assume that the numbers turn out to be 1 to 2 to 1, that is x, y, and z. What that means is that at the molecular level, okay, you're going to have 2 atoms of hydrogen for every atom of carbon and for every atom of nitrogen. Okay, so that's essentially what happens at the atomic level. Now, of course, we're not going to be doing experiments at the atomic level. That is exceedingly difficult, but we can do experiments at the macroscopic level. And at the macroscopic level, we use the mole as a surrogate for those atoms, right? So notice that if you have, again, 1 mole of this species, not 1 molecule, but 1 mole, then the number of moles of hydrogen total would be 2 compared to 1 of carbon and compared to 1 of nitrogen. So somehow, if we're able to determine the number of moles of each of the elements in this compound by doing some experiments, then we will have, eventually we'll have these coefficients. Okay, so the question is, how are we going to do that? How are we going to determine the number of moles of each element in that compound? Well, notice that we actually have the molar mass for carbon, hydrogen, and nitrogen. That is given directly in the periodic table, right? So if we get the mass of each element, we divide by the molar mass of each one of them, and then we'll have the number of moles for each element, right? So again, notice how the problem is flowing. We need the moles, but we can get them from the mass. So we're now trying to determine an experiment that is going to give us the mass of each element in this compound. And again, from the mass of each element, we will be able to get the moles of each element, and the moles are directly related to these coefficients that we need to know. All right, so how do we determine the mass for each element in this compound? Well, what we're actually going to do is we're going to run a reaction that is going to be able to separate the elements in various compounds so that we can actually analyze the mass of each element in the products. Okay, so the experiment that we actually run here is going to be a combustion. Okay, so we're going to burn it with oxygen, and then the products that you generate are going to be CO2, and then H2O. And these are the products that you get when you burn something that contains only carbon, hydrogen, and oxygen. In this case, we also have nitrogen, so we have to worry about that other product, which is going to be N2. Okay, notice how nice this is. If the reaction runs to completion, all of the carbon atoms that we have in this compound are going to end up in CO2, right? So if we're able to measure the mass of CO2 with the percent composition of carbon in CO2, which we know how to calculate, then we can know how much of that mass of CO2 that we've obtained is due solely to carbon. And then by the conservation of mass law, then all of the mass of carbon that we get in CO2 must have come from the mass of carbon that we had initially, right? So that is a great way to determine the mass of carbon that you had in reagents by just measuring only the mass of carbon that you have in this unique product, CO2, okay? The same thing is going to happen for hydrogen. Notice that the only product in which you have hydrogen will be water, right? So if you're able to measure the mass of hydrogen in this water product, okay, by the law of conservation of mass, that is going to be exactly the same mass that you had here in the compound, okay? And the same thing happens for nitrogen. So then the strategy is clear. Again, we're going to burn this compound with oxygen, and then we're going to generate products, and then we will selectively separate CO2 from water from N2O, and then determine the mass of each element in these product molecules, trace it back to the masses of the products, calculate the moles, and then that will give us the formula. As you can appreciate, this is going to be a long process, so we're going to stop this video here, the strategy video, and then in the next video we're actually going to run the numbers.